Hello 108 students, Mr. McHugh here with you. Welcome back to the last page of 3.3. We're going to knock off page 6 here. It's been a little bit of a long section here. Example 5b is similar to what we did in 5a, except this time they'd like for us to find the line of a line that's perpendicular, and that's what that symbol means, perpendicular, which means 90 degrees, through the equation 2x plus 3y equals 6, through the line at the point -4, 5. Okay, now what we need to remember is what is the perpendicular slope of a line. That's the opposite reciprocal. Now I said from example 5a we found from the previous example that the slope was -2/3. Okay, how do we do that? We isolated the y variable. Now I already did that before, but if I'm going to work upwards. This is a little strange, but minus 2x on both sides would leave me 3y equals -2x plus 6. Now divide both sides by 3. Y equals -2/3 x plus 2. And that's where that -2/3 comes from. That's the slope m. It's always the coefficient in front of the x term. Okay, now that we have that, all we have to do is ask ourselves, what is the opposite reciprocal? This is a critical part of this problem. Students will forget this. So you take the 2/3, you write the reciprocal, flip the numerator and the denominator, and write 3/2. Take the sign from negative and make it a positive. Now you don't actually have to write the positive sign, but I'm just trying to show that to emphasize. Okay, now that you've got the slope is a positive 3/2. Method number 1 is what I happen to show here. I'll call this the old school technique. You know the slope was 3/2, substitute it in. You know that you're going to use the working formula, y minus y sub 1 equals the slope times x minus x sub 1. X sub 1, y sub 1 is the ordered pair. So -4, 5, there's the values form right here. And so for y, and watch this, I keep telling my students, when you substitute y sub 1, it's not the x. A lot of people will stick that -4 and stick it in here. You got to put the 5 in, so be extra careful. It's y minus y sub 1. There's the slope, 3/2, parentheses, x is your variable, x sub 1 is -4, so it's a minus from the subtraction, and there's the negative with the -4. That turns it into addition. Okay, be careful with the signs. Watch your sign. Okay, now from here, I cleaned it up. I did a distributive property, and when you take 3/2 times 4, watch, 2 goes into 4 twice, 2 times 3 gives you the 6. That's where the 6 came from. Now you need to isolate the y variable. It's always isolating the y, so add 5 to both sides, and voila, you get y equals 3/2 x plus 11. Okay, now if you had wanted to use the method number 2, you would have turned around and said y equals mx plus b, the golden formula. See if I can squeeze this in here. Y would have been 5, slope still would have been 3/2, x would have been -4, and you would have solved for b. And I'm not going to do the arithmetic, but you would have gotten 11. And you might like this because that's pretty easy to do when you do this. And then you turn around, you know that the b, the y-intercept is 11, the slope is 3/2. That's the opposite reciprocal from the original line. You simply substitute them in and you'd be done. Okay, so they asked for that one to be written in y equals mx plus b. If for some reason, if for some reason they wanted you to write that in standard form, I would have seen that fraction of a 2 and multiplied everything by 2, and I would have had 2y equals, now multiply everything by 2, 2 over 2 cancels out, 3x, 3 times 11 would have been 22. And the last thing you would have need to have done is, well, actually I should bring this up here. Let's go ahead and work this out, because this brings up a little interesting point. Now I would minus 3x on both sides, minus 3x plus 2y equals 22. Now one little nitpicky, it's ax plus by equals c. This is important that you remember that you must have a positive coefficient starting out the form. That's just a protocol that mathematicians like, so I would have had to have multiplied everything by a -1 across the board. Okay, when you multiply every term by -1, you maintain balance. And, excuse me, that's 3x minus 2y equals minus 22. Okay, so that's, I'm glad I worked that out there just to make sure you see that. You never, the leading a term on ax plus by equals c must always be positive. Okay, now I have a big note here. I say study and master the forms of the lines, and I'm referring to the table that is on page 166. Now it's a summary table. Okay, you need to look at this, look at, maybe some of it might look like it's in Lorie's form. See if you can understand the 3 different forms I've got there. The first 3 equations, the bottom 2 are horizontal and vertical lines. We've covered all that. Just make sure you've mastered those equations and you feel comfortable with them. Okay, now one of the last problems I give here in this section here is a fairly easy application problem. I love linear equations. I haven't done a lot of bragging about it here on these talking class note videos, but in class I really go crazy with the real life applications of linear equations, and this is just an example right here. I like this. Is fairly close to being the price of gas right now. Of course, I'm seeing it at about $3.75, but this example 6 matches example 7 in the book. And if you've been, I haven't said this before, but my class notes come from the previous version of this book, and we went to a new one last fall, and most of the examples line up. There's a few that don't. So these class notes are from version 10. This is version 11 of the book, but this is example number 7 in your book, not 6. And what it says here real quick is, hey, if you pay $3.20 per gallon for gas and you're going to go to a car wash, I see lots of lot of gas stations around here got the car wash. It's $3 per car wash. Could you write an equation to help you figure out how much money it would cost you? And so the idea here is to let x equal the number of gallons that you're going to buy. Y would be the cost. We're going to get into this in the next section. This is called a function, and you're going to use y equals mx plus b, and you're going to realize that the slope is the rate. You pay what, $3.20 per 1 gallon. So it's $3.20 per every 1 gallon. Okay, that's going to be your rate. That turns into your slope of the line. X is how many gallons, and you're always going to add, starting off with, you got to buy $3 of a car wash. So you simply take the values, plug them in, and you're done for these problems. These ones aren't too bad, and I just want to get you some exposure. Wish we had more time. Real life applications. I went for my master's of business administration. Was the first time I saw all the years of algebra up to calculus in the past that I used, that I saw linear equations being used. Okay, in fact, we'll do that in chapter 4, showing some of that with business applications. Now, this example 7, it's not in the book anymore. I took it out of the homework. It was a great example of figuring out, calculating college costs here from 1990 to 2002, and it went from 2035 to 4273, and that rate of increase, you were trying to use it to predict what it could be in the future. So I'm just going to pass on this here with the chicken scratch notes. Without it being in the book, it's really hard to figure out. So we'll just let that go for now, and it's not on your homework. So, okay, Mr. McHugh going to say, wrapping it up here for section 3.3. Page 6 is done. When I see you again, we are going to skip 3.4 is a skip, and I will see you for 3.5. Okay, that's all for now. I'll see you later. Bye.